We expect James Webb to make great discoveries. We expect that. When you put like quantum physics and general relativity and you try to come up with some bigger understanding, deeper understanding, string theorists have been all into this, you get a multiverse.
Have you ever wondered if there are other intelligent beings in the universe other than Earth? While that may not sound so frightening, what if you have duplicates all over the place like the universe? The theory of the hot Big Bang, which proposed that the universe as we know it today arose from a hotter, denser, more uniform past, was one of the biggest scientific accomplishments of the 20th century. The Big Bang is frequently depicted as the beginning of everything: space, time, and the birth of matter and energy. This makes sense from an archaic perspective. If the universe we perceive now is expanding and becoming less dense, it must have been smaller and denser in the past. But the idea that there could be copies of you means that there could be copies of almost everything you know. This means a form that looks just like you doing things you do, which sounds unsettling, but the hypothesis was supported by one of science's brightest minds, the late Professor Stephen Hawking. He worked on the multiverse theory, which seeks to explain why you may have clones that you are ignorant of. Although Professor Stephen Hawking died before the James Webb Space Telescope was launched, many hours of the new space telescope will be dedicated to testing some of his theories. One of those hypotheses is the final one Hawking worked on before his death, in which he argued the multiverse theory, which proposes that an exact replica of you exists in a parallel reality. But what is Stephen Hawking's multiverse theory? What role does the James Webb Space Telescope play in proving the theory? It sounds so fascinating that replica of this planet or star in the solar system or the entire Milky Way galaxy, even your laptop or Range Rover may also have duplicates. Sometimes I think the surest sign that intelligent life exists elsewhere in the universe is that none of it has tried to contact us, Bill Watterson said. The multiverse theory is notable because it was the professor's final published work, which was submitted for publication just 10 days before his death in the paper titled A Smooth Exit from Eternal Inflation, which he co-authored with Thomas Hertog, a physicist at Belgium's Catholic University of Leuven. Hawking offered a theory for the origins of the universe that might provide answers to certain outstanding issues. Indeed, if the Webb eventually demonstrates the existence of the multiverse, the scientists behind it will be likely candidates for a Nobel Prize. However, because Nobel Prizes cannot be awarded posthumously, Hawking would be unable to receive one. What was the late physicist's opinion on multiverse? The multiverse theory posits that our universe, with its hundreds of billions of galaxies and virtually uncountable stars spanning tens of billions of light years, is not the only one. Rather, there may be another world distantly removed from ours, and another, and another. In fact, this mind-bending theory offers an endless number of universes, each with their own rules of physics, and potentially even their own intelligent civilizations. So, in essence, our universe could be one of a much larger, far bigger number of universes, known as the multiverse. The multiverse concept exists in numerous disciplines of physics and philosophy, but the most well-known example comes from the inflation theory. But what does it have to do with the universe? Inflation theory depicts a hypothetical event that took place when our universe was only a fraction of a second old. The universe expanded rapidly in that short time, expanding to several orders of magnitude larger than its previous size. Inflation in our universe is thought to have ended roughly 14 billion years ago, although inflation does not end everywhere at the same time. While inflation has ceased in our universe, it is likely that it has continued and is now continuing in much more remote areas. This could explain why our universe has certain characteristics, particularly those that are difficult to explain using fundamental physics, such as dark matter or the cosmological constant. According to some scientists, the emergence of intelligent species capable of making cosmic observations is the most persuasive proof for the multiverse. Certain aspects of our cosmos look distinctive and necessary for supporting life when regarded in this perspective, such as star longevity, carbon abundance, light availability for photosynthesis, and the stability of complex nuclei. Having a theory is one thing. Being able to test it is quite another. Because of the complexities involved, proving the multiverse theory is a challenging step. Going back in time to re-examine many processes and events that occurred before we appeared as a universe is required for evidence. When we talk about gazing back, We're talking about billions of years all the way back to the Big Bang. Where will scientists get the essential tool to accomplish this? Astronomers have become fond of the Hubble Space Telescope, which deserves to be inducted into its Hall of Fame. However, Hubble can only look so far back in time. While the GNZ11 galaxy is approximately 13.4 billion light-years away, Hubble saw GNZ11 as it was approximately 13.4 billion years ago, and that is the telescope's limit. The Big Bang happened 13.7 billion years ago. Therefore, there is a 300 million year gap between that event and the extent to which Hubble can peer back. That gap includes crucial information. This is where the James Webb Space Telescope, the mother of all telescopes, comes into play. The infrared instrument on the JWST enables it to focus on brilliant objects such as very distant galaxies. The JWST's mission is to look for the first light in the universe and celestial objects that appeared right after the Big Bang. Examine the development and evolution of galaxies, investigate the atmospheres of distant exoplanets, and look for evidence of dark matter. Hawking, who helped establish the theory that led to the concept of endless parallel universes, acknowledged in an interview that he had never been a great fan of the multiverse, adding, "The usual theory of eternal inflation predicts that globally our universe is like an infinite fractal, with a mosaic of different pocket universes separated by an inflating ocean. The local laws of physics and chemistry can differ from one pocket universe to another, which together would form a multiverse. But I've never been a fan of the multiverse. If the scale of different universes in the multiverse is large or infinite, the theory can't be tested." Physicists could look for evidence of other universes by using sensors designed to measure ripples in space-time created by the universe's earliest expansion following the Big Bang, commonly known as primordial gravitational waves. Of course, scientists must debate on everything, but we are thrilled that humans are getting closer to discovering whether other sentient life forms exist in parallel universes. But by peering beyond the visible spectrum of light, there's literally no telling what Webb might learn about the birth of the universe. And that's kind of the reason NASA built it. The more we learn more about our universe, the more we realize that Webb is critical to answering questions we didn't even know how to ask when the spacecraft was first designed. Tell us what you think. Will Webb finally be able to prove multiverse in its entirety, or will we have to wait for future technologies? As always, thanks for watching our video. See you in the next one.